Good evening, students. Welcome to class 11th physics. Today we are going to discuss the projectile motion. The topic belongs to motion in a plane. Yeah, motion in a plane. Already in our last class we discussed about motion in a straight line. So today we are going to discuss in a motion in a plane. So before entering into our class, uh, let me show you one picture to discuss the motivational story. Yeah, yes. Look at the image projected on our screen. Is it visible? Okay, good. Let us travel back nearly 400 years to the year 1632. 1632. Okay. So imagine standing high upon a sea cliff alongside the great Italian physicist Galileo Galilei. Yeah. Galileo is holding two identical heavy ion cannonballs. You can see that. Okay. So cannonball A is going to be dropped straight down. So you can see that dropped straight down here. Yeah. So dropped straight down off the cliff. Cannonball 3B is loaded into a cannon and fired horizontally out over the ocean at high speed. Okay. So now before I tell you what happens, let me ask all of you a quick question. Which cannonball will hit the ozone floor first? Which cannonball will hit the ozone floor first? The one dropped straight down or the one blasted horizontally at high speed? Which cannonball will hit the ozone floor first? You can type the answer. Dropped down ball or horizontal ball? Which one hit the ozone floor first? Yes, good. Okay, right. So, some of the students may think about that. The dropped one is the answer because we may know that dropped one because it has a shorter path, or the fired one because it is faster. Yeah, like so. Most people instinctively think the dropped ball hits first because it travels in a short, straight, vertical line. Is it correct? Most people think about that in that way. Yeah. The dropped ball hits first because it travels in a short, straight, vertical line. While the fired cannonball has to travel hundreds of meters sideways, in a sideways. Yeah. But look at that Galileo's banner at the top of our screen. Okay. Both cannonballs hit the ground at the exact same instant. Clear? You can see that in the picture. Both cannonballs hit the ground at the same exact instant. Take a look at the stopwatch icon, and the block dots indicate the time steps. At t is equal to 1 second, t is equal to 2 seconds, t is equal to 3 seconds. Both balls are at the exact same vertical height level all the way down until they crash into the ground together. Yeah, is it clear? So why? What is the reason behind that? So deconstructing the physics. Here is the part why. You can see in the center why. Because gravity acts vertically and does not care about horizontal motion. Is it clear? Why does this happen? The banner gives us the answer. Because gravity acts vertically downward and does not care about horizontal motion. So Galileo's groundbreaking insight was that 2D motion is simply two completely independent 1D motions happening at the same time. 2D motion is simply two completely independent 1D motions happening at the same time. Okay. So now let us break down these two independent components shown in the cards on the right. First one is horizontal motion, red box. Second one is vertical motion, blue box. First one is horizontal motion, red box. Once the ball leaves the cannon, no horizontal force pushes or pulls it. Yeah, there is no horizontal forces. Pushes or pulls it on the horizontal direction. So assuming there is no air resistance, okay. So therefore, there is no horizontal acceleration. So that's why I am putting Ax is equal to 0. There is no horizontal acceleration, Ax is equal to 0. Then horizontal speed Vx is equal to Ux, which is remains completely constant throughout the flight. Clear? This means constant. And position equation x is equal to uxt, a linear relationship with the time. Clear? So these are for all for horizontal motion. Then next one, vertical motion, blue box. Here you can see that important data. Gravity continuously pulls the ball downward with the constant acceleration. So that means gravity pulls means Ay is equal to minus g. That means minus 9.8 meter per second square. So gravity continuously pulls the ball downward with the constant acceleration. So both balls started with initial vertical velocity of 0. That means uy is equal to 0. Yeah, uy is equal to 0. Because both balls started with initial vertical velocity of 0. uy is equal to 0. And vertical position equation, you can see that y is equal to uit minus half gt square. Clear? And velocity vy is equal to uy minus gt. So depends only on gravity and the initial vertical velocity. Clear? So since gravity pulls on both balls with the exact same acceleration g, their vertical drop is 100% identical. Okay, since the gravity pulls on both balls with the exact same acceleration g, their vertical drop is 100% identical. Now we are going to the general result and the big takeaway. Clear? So you can see that general result box. The path is a parabola because. So what happens when you combine these two motions? X depends on time, t linearly. That is, x is directly proportional to t. Y depends on time, t quadratically. That is, y is directly proportional to t square. So when you eliminate time t, you will get y is directly proportional to x square. You can put that y is directly proportional to x square, which is mathematically creates a parabola. Yeah, y is directly proportional to k square, x square means Already you knew about that equation in our mathematics, which is a equation for parabola. Yeah. That's why every thrown object, a football, a cricket ball, a cannonball, traces a beautiful parabolic curve in the sky. Clear? Clear? Okay. So our big takeaways for today's lesson: horizontal and vertical motions are completely independent. You should know that horizontal and vertical motion are completely independent. One is. Second one is gravity affects only the vertical motion of the motion. So gravity affects only the vertical motion. Okay. Third one, understanding this simple pattern allows us to predict the trajectory of any object in nature. So now that we understand Galileo's brilliant principle, let us test our understanding with a quick 3-question icebreaker before we launch our interactive virtual simulation. Now I will share the interactive, 3 MCQ question once again. So here you can see that 3 important fundamental questions. You can chat in the, you can type the answer in the chat box. What is the value of sine 30 degree and cos 60 degree? The value of sine 30 degree and cos 60 degree. You can tell. Yes. Answer is 0.5 or 1/2. Clear. Very good. Yes. Option B is the correct answer. Then next question. If the object moves horizontal with a constant velocity and no horizontal force on it, what is horizontal acceleration? You may recall our initial introduction. Yeah. If an object moves horizontal with a constant velocity and there is no horizontal force acts on it, what is its horizontal acceleration? Good. 0 meter per second square. Very good. Super. Because velocity is constant. So acceleration 0. Very good. And the final one, if the velocity vector v acts at an angle theta with the horizontal, what are its horizontal vx and vertical vy components? Already you know about that. So when the force or velocity, it makes angle with theta with the horizontal floor or horizontal axis, that force or velocity split into 2 components. Already you know that. Yeah. One is vertical component and another is the horizontal component. So what is the value? What is the answer here? For horizontal motion, for horizontal component, Vx. For vertical component, we can take that Vy. So Vx equal to, yes, good. Option C is the answer. V cos theta and vertical component Vy is equal to V sin theta. So here V means initial velocity. Yeah. So that velocity is split into 2 components with respect to theta. So horizontal cos theta, vertical sin theta. Yes, good. So now we can see the answer. Yes, all of the 3 correct. Very good. Clear? Okay, super. So now we will enter into the important simulation. So I will share the screen again now to show the projectile motion. Clear? So here you can see that. Okay. So look at our simulation screen on the left. We have a cannon launched at an angle something and with a velocity of something. So we can put that values here. So first of all, click the components and set initial velocity 28 meter per second. Clear? Here 28 meter per second. Launch angle theta naught 30 degree and gravity G is equal to 9.8 meter per second square. Okay. Clear? Okay. And look at the live numbers on the right chord under initial velocity resolution. Here you can see that. So already we know that formula V OX is equal to V naught cos theta naught. V naught Y equal to V naught sin theta naught. So here is a velocity components. Yeah. Okay. Good. So first of all, suppose we have a V naught 28, theta 30 degree. So we can put that values in this formula. So we will get these values. Correct? V naught means initial velocity 28, theta naught in launch angle 30. So 28 into cos 30, 24.25 meter per second, which is shown in the formula shown in the block, blue box, blue color. Okay. So answer also in the blue color. For the vertical velocity, Vy, V naught Y, okay, V naught into sin theta naught, which is the formula for vertical velocity. So now we can put that same value, V naught 28, sin theta naught 30. So we will get the answer here. 28 into sin 30, which is equal to 14 meter per second. Clear? Okay. So now closely watch as I change the angle slider. Okay. So look at those values. Okay. Now I will move the launch angle from 30 to 60 degree. You can see that value changes. 30 to 60 degree. Yes. Clear? So the values are changing. That is interchanging. Yes. Good. Interchanging. Clear? Okay. And also you can see it in the figure, that is launch angle 60 degree. So the angle changing. Yeah. So notice what happened to our components at 60 degree. What happened to our components at 60 degree? So V naught X decreased from 24.25 meter per second down to 14 meter per second. And V naught Y increased from 14 meter per second to 24.25 meter per second. Is it correct? Is it correct? Yeah. Yes. So as the launch angle becomes steeper, the projectile trades horizontal speed for vertical speed. As the launch angle becomes steeper, the projectile trades horizontal speed for vertical speed. Okay. Now I will launch the projectile. Here you can see that. Clear? Yeah. Okay. Good. So watch the blue color arrow and purple color arrow. Yeah. Watch the blue color arrow and purple color arrow. Yes. So the horizontal blue arrow, that is Vx, never changes. You can see that. Yeah. That vector arrow never changes. So never changes length. Why? Because horizontal acceleration Ax equal to 0. Horizontal acceleration Ax equal to 0. So that's why, that means Vx is constant. So its length never changes. So horizontal acceleration Ax equal to 0. Clear? The purple vertical arrow Vy shrinks as the ball ascends. Yeah. as the ball ascends, becomes 0 at the peak and flips downward. As it falls under gravity, Ay is equal to minus G. You can see that purple vertical arrow. Clear, students? Good. So if I set the launch angle theta naught is equal to 0. So launch angle theta equal to, once again, so theta naught equal to 0 degree. That is horizontal launch. Think about that. What will be the value of V naught Y? What will be the value of V naught Y? Yes, exactly. At theta naught equal to 0 degree, sine 0. Sine 0, already we know that 0. So 0 and anything 0. So there is no vertical velocity component. Is it clear? There is no vertical velocity component. The entire initial velocity goes into the horizontal motion. That is V naught x is equal to V naught. Clear? So that's why you can see that answer here. 28 into cos 0 degree. Cos 0 means 1. So initial velocity. So entire initial velocity goes into the horizontal motion. Horizontal vertical component. V naught x. So V naught x is equal to V naught. Is it clear, students? Is it clear? So what happens when theta naught equal to 0 degree horizontal launch? At theta is equal to 0 degree, Vy equal to V naught y equal to 0 meter per second. V naught x is equal to V naught. The entire initial speed goes into the horizontal motion. Is it clear? Okay. Now we go into the next tab, that is trajectory path. Clear? So now let us answer a fundamental question. What is the exact geometric shape traced by the projectile in the air? What is the exact geometric shape traced by a projectile in the air? So now look at the panel. Already you know that equation. Y is equal to tan theta naught into x minus g by 2 into v naught cos theta naught the whole square into x square. This is the formula. Is it clear? Okay. So first of all, we can set the values here. So initial velocity 28 meter per second. Theta, launch angle theta, we may set into 30 degree. Okay, 30 degree. G 9.8 meters per second square. Okay. So now look at that right panel. By eliminating time, that is t is equal to x by v naught cos theta naught from our position equations, we get the equations. This is, yeah, we get the equation of path. This is with our current slider values, the live equation calculated these values. Y is equal to 0.577x minus 0.0083 x square. Yes. Okay. Since this matches, y is equal to ax minus bx square. Yeah, you can see that ax minus bx square. So this is a equation for parabola. The trajectory is a parabola. Yeah, the trajectory is a parabola. Okay. Now look at the slider. So I will increase the angle. I will increase the initial velocity first. So 28 to 45 seconds. 28 to 45. Okay, good. Look at that equation. Now, as a speed V naught increases to 45 meter per second, the coefficient, that time will increases because of V naught increases. Yeah. So G by 2V naught cos theta naught square drops from, here you can see that, drops from 0.0833 down to 0.032. Is it clear? Because of this initial velocity increasing. The smaller coefficient of x square means a flatter, wide parabola that stretches much further across the landscape. Is it clear? Okay. Now I will drag the gravity slider up to 20 meter per second square. So here you can see here gravity 9.8 meter per second square. Now I will drag the value into 20. You can see that value changes here. (20 meter per second square). So now look what happens if if gravity increases to 20 meter per second square, like on a heavy high gravity planet, the s square coefficient shoots up. The trajectory bends sharply down into the steep parabola. You can see that, yeah. So that time, that value changing. Now 0.00658 because of this gravity value. Good. Okay. Now we will move into the next step, that is time of flight. Already you know that the formula at peak height Vu is equal to V naught sin theta naught minus T minus G into Tm equal to 0. Tm means maximum time for the maximum height, that is peak time. Formula V naught sin theta naught by G, and Tf time of flight 2V naught sin theta naught by G, which is 2 times the time of peak time, that is 2 into Tm. It is clear? At maximum height, the vertical velocity becomes 0. Vy is equal to 0. The total flight time Tf on a ground level is exactly twice the peak time, that is Tf is equal to 2Tm. Is it clear? Okay. So now let us look at how long the projectile stays in the air. On the right panel, you can see the two formula. One is peak time Tm, that is the time to reach the maximum height, where Vy is equal to 0. So Tm is equal to V naught sin theta naught by G. So now you can set the value. For example, initial velocity 28 meter per second square, meter per second. Okay. And theta 30 degree and G 9.8. 9.8. Clear? So V naught 28 sin theta naught sin 30 degree by G 9.8. You can put that values in the formula. You will get the value 1.43 seconds. Okay, you will get the 1.43 seconds. And the total time of flight, that is TF, total time until landing. Total time until landing. So TF is equal to 2 into Tm. So which is the exactly double the time to peak. So 1.43 into 2, you will get the 2.86 seconds. This is the value for time of flight, TF. Is it clear? So note that the time, total flight time is exactly double the time taken to reach the peak, because parabolic motion is symmetric. Parabolic motion is symmetric. Clear? Okay. So now check the check the box slow motion, then click the launch angle, launch projectile. You can see that. Okay. Okay. So when the red ball reaches the peak line marked as HM. So wait and see. I will pass that red ball exactly at the maximum height. Yes, clear? Maximum height. So HM is equal to 10 meter. So here you can see that by the formula 1.43 second we got. Yeah. Here also you can see that. Here also times equal to 1.42 or 43. Okay. This is because exactly, which is exactly at the maximum height. You can see that. Yes. Yeah. Now we will get the 1.43 second. So look at that telemetry overlay at the top left of the simulation canvas, which is reads 1.43 second, exactly matching our theoretical TM. Yeah, here also 1.43 second, here also 1.43 second, which is exactly matching our theoretical TM. Yeah, so vertical velocity Vy. Vy, you can see that Vy is equal to 0 meter per second. Yeah, because at the peak height, at the maximum height, vertical velocity is 0. Okay. So now resume and watch it descend for another 1.43 second to land at our total time. Yeah. Now you will get that answer. 2.86 second. Here also 2.86 second. Is it clear? Because it takes time to land at the floor at t is equal to 2.86 second. So lands the angle changing from 30 to 60 degree. If I increase the angle from 30 to 60 degree, sine 60 0.866, yeah, which is larger than the sine 30 because sine 30 is 0.5 only. So now look at that values, time to peak and the time of flight. Clear? So watch the calculation update live. Peak time increases from 2.47 second to second, and the total time of flight increases to 5. Yeah, like that. 2.47 or 2.50 second to time of flight 5 seconds. Clear? So launch angle changing, the data also changing. Now we are moving into the next step, that is maximum height. So maximum height means it is the highest vertical displacement reached during flight. Yeah, which is the highest vertical displacement reached during flight. So for vertical, for the maximum height, we can set that value. Vertical initial speed V naught equal to 20 meter per second. For example, okay, 20 meter per second. Okay, theta naught 60 degree. Sorry, 30 degree. G 9.8. Okay. So already we know that the maximum height formula HM is equal to V naught sin theta naught the whole square by 2G. Is it clear? So V naught is equal to 20 and sin theta naught 30 degree. You can put that value 20 into 0.5 the whole square by 2 into 9.8. You will get the 100 by 19.6 and which gives a 5.10 meter. Yeah. You can put that values in this formula. V naught 20, launch angle 30, gravity 9.8. So you can see that the maximum height 5.10 meter. Is it clear? Here also you can see that 5.1 meter. You can see the light blue dashed marker line in the simulation indicating HM, that is 5.1 meter. Is it clear? Okay. So now I will increase the velocity into 40, that is double the velocity. Yes. Observe this carefully. I am doubling the launch speed from 20 meter per second to 40 meter per second. Does the maximum height double to 10.2 meters? 10.2 meters. HM now changing 20 square by 2 into 9.8 because 20 from V naught into sin theta naught, V naught 40, sin theta naught 30 degree, same value. So 400 by 19.6, you will get the 20.41 meter. Is it clear? So it did not double, it increased by 4 times because in previous cases for the velocity v is equal to 20 meter per second, the maximum height only 5.1, but now 20.4, so increased by 4 times. Why? Because maximum height is proportional to the square of the initial velocity, that is hm is equal to hm directly equal to v naught square. You can see that the formula. Is it clear? So that's why it increases by 4 times. Okay, right, clear. And you can see that also, that is launch angle 90 degree, sin 91, that is vertical throw, which gives us the absolute highest possible altitude for that speed. Okay, so 81.6 meter, this is the maximum height. If we land the straight up at 90 degree, sin 90 degree becomes 1, gives us the absolute highest possible altitude for that speed. Okay, 81.6 meter. Now we can go into the horizontal range. So our final concept is horizontal range, which is a total horizontal distance covered from launch to landing. That is y is equal to 0. So you can see that formula, r is equal to v naught square sin 2t naught by g. Okay, so for this we can set that values initial speed 28, like that, 28, theta is equal to 90 degree, 60 degree, g is equal to 9.8. okay, at the angle theta is equal to 30 degree, r is equal to 28 square because v naught 28 sin 60 or 30, for theta is equal to 30, but sin to theta becomes 60. Okay, so sin 60 by 9.8. So 784 into 0.866 by 9.8, you will get the answer 69.28 meters. Look at that purple dot on the ground in our canvas. It marks r is equal to 69.3 meter. Clear? Now lands a projectile. Note where it lands for that angle 30 degree, 69 point. So now change the angle from 30 to 60 degree. Okay, now lands the projectile. Now, yes, so now range 69.3 meter. Is it clear? So the trajectory at a 60 degree goes much higher in the air, but it lands at the exact same spot. Why? Because sin 2 into 30 degree, sin 60 degree, and sin 2 into 60 degree, sin 120 degree, both equal 0.866. Yeah. So this is an important rule, important key. Complementary launch angle, that is theta naught and 90 minus theta naught, always produce the exact same horizontal range. Always produce the exact same horizontal range. Is it clear? And for the maximum angle 45. Now launch the projectile. You will get the r is equal to 178.9 meter. Is it clear? So launch at that angle 45 degree, 2 theta naught, becomes 90 degree. So theta naught 45 degree maximize the range. So at 45 degree sin theta 2 theta sin 2 theta maximum 90 degree. Okay. So R max equal to V naught square by G 28 square by 9.8, which is gives a 178.95 like that. Yeah. So for the maximum range, you have to throw the ball at a 45 degree. Clear? So 45 theta naught 45 degree, 2 theta naught 90 degree. So R max gives that value. Is it clear? Okay, super. You can see that. Now launch the particle. Yes. So initial speed changes and launch angle 45 degree. For the every changing of launch angle, so 45 degree gives a maximum range. Is it clear? So to summarize our 5 core takeaways, horizontal velocity Vx equal to V naught cos theta naught remains constant throughout the flight. That is Ax equal to 0. The trajectory is a parabola. That is y is equal to Ax minus Bx square. And vertical velocity Vy is equal to 0 at peak time Tm. And the total flight time Tf is equal to 2 Tm. Maximum height Hm is proportional to the V naught square. And the maximum horizontal range occurs at the launch angle theta naught is equal to 45 degree. And the complementary angle gives equal ranges. Is it clear? Okay. Now we will go into that one problem. I will share the screen again. Okay, right. So problem number 1, cricket ball launch. So here you can see that a cricket ball thrown with the initial velocity V naught is equal to 28 meter per second at an angle theta naught is equal to 30 degree to the horizontal. Calculate the maximum height Hm, the time of flight Tm, and the horizontal range. Is it clear? So take a look at the diagram first. We have our initial velocity vector in blue launched at a 30 degree angle. The dashed line shows the parabolic trajectory. We need to find 3 things: how high it goes, the red line; how far it goes, the green line; and how long it stays in the air. Is it clear? So let's start with the part A, the maximum height. Okay, right. So who remembers that what component of the velocity determines how high the ball goes? What component of the velocity determines how high the ball goes? Yes, correct. That is vertical component, Vy. Exactly. The vertical component. Let's see the formula. Next step. At maximum height. So this is the equation. Notice that sin theta naught in the formula. So Hm is equal to V naught square sin theta naught by 2g. That sine function is extracting just a vertical part of our 28 meter per second square throw. Let's plug into our numbers. We substitute 28 meter per second for V naught and 30 degree for theta naught and 9.8 for G. Since the sine of 30 degrees, which gives 0.5, our vertical velocity component is just 14 meter per second square. Is it clear? 14 meter per second. Let's calculate the final value. Hm is equal to 10 meter. You can see that. You just to put those values. Clear? Okay. Super. So the ball reaches the maximum height of 10 meters. Now let's figure out the how long it's in the air. This is the time for flight. This is a time for flight. So next step. Already you know that the equation for time of flight, Tf is equal to 2v naught sin theta naught by g. Is it clear? It relates only on the vertical amounts, v naught sin theta naught and gravity. So gravity is what brings it back down, yeah, dictating the time. So plugging in our values, we will get that Tf. So 2 times 28 times the sine of 30 all over 9.8. The ball is in the air for 2.9 seconds. Finally, how far down the pitch does it land? Now let's find the horizontal range. So you can put those values just like that. Okay. Next step. For horizontal range, this is the formula. R is equal to V naught square sine 2 theta naught by G. Is it clear? Okay. Since our angles is 30 degree and 2 theta naught 60 degree, we plug everything in it. The sine of 60 degree is about 0.866. Yeah, 0.866. So we will get the range of approximately 69 meter for these values. Okay. So now let's look at a quick notes. This is a golden rule of projectile motion. Horizontal and vertical motions are independent. The vertical motion describes the time in the air. The horizontal motion just coasts along at a constant speed for the amount of time. Time is only bridge between the two. Is it clear? Okay, students. So that's all for today. So if you have any doubt, you can type in the chat box. You can see that problem and you can do it yourself. Put those values in that formula. Okay. Any doubts? Okay, no doubts. Okay. So let's complete our class. Thank you. Thank you, Vidyasati. Thank you, Bharat. Thank you, Jai Hind. Thank you.